What do we have? What's the first indicator? Okay. What's the second indicator? What's the third indicator? Okay. Now, talk to me. Out of these three, which one is used when I have a strong acid and a strong base? Strong acid and a strong base. Okay. So, this one is the one we use for neutralization, from a thermal blue. And then, when do we use methyl orange? So, this one we use it when we have a strong acid and a weak base. Okay. And then, when do we use this one? Yeah, basic solution. A strong base and a weak acid. Beautiful. Now, what we're going to do today is, what's this thing? Titration. Now, very important words you need to know. What is this called? What is this called?
What stand?
Rheostat stand. Or rheostat stand. I don't know what word this is. I'll give you the words.
Say assistant.
I'm
Assistant.
here. Right. I'll call you. And then what do you call this one?
What flask?
This is a beaker.
What flask?
Okay. There's a conical flask or Ellen Meyer. Yeah. I don't know what. It's also a flask. This is also a flask. So now, two things that are gonna confuse you. What do you call this? Burette. This is a burette. This is a burette. Now, what's the function of a burette? It's to measure the volume of the known concentration. So, the function of a burette is to measure the volume of the known concentration and to also put it inside the flask so that it doesn't spill. So, guys, people are going to get confused between these two. What is this called?
Burette.
Nice. What is this called?
Thermometer.
A thermometer measures the temperature. What is this called? Okay, it's fine. By the way, this is called a pipette. Pipette. Burette, pipette. I'm not going to tell you why it's called a pipette, because you guys are going to think funny things. This is called a pipette. I'm not going to tell you why, because you're not just look at the shape. Alright. Now, look here. And then what you do, guys, I'll give you a drawing. I'm going to show you what you need to do. You're going to do a formal write-up as well. So please listen properly. Okay. I close this thing. Now, is this a burette or pipette?
Burette.
Where does it start measuring? At what? What's the initial measurement? Okay, look here. Where does it start? The first initial measurement is always at 0. So high at 8, it's going to read 0. When it's empty, it's going to read 51 watt. Do you see? So Yona, it's opposite. So Yona, when it's empty, it measures 0. 50. 25. Okay, 25. When it's full, it measures 0. We count them. Okay. And then I'm gonna need. Okay. Let's go fetch a funnel. Okay, go. I'll show you. I'll show you what it is. Something hurry. Okay. That thing is abang. It's chelang paraffin. Go inside. I'm inside. Okay. Two is abang. Yeah, take two. Yes.
Yes.
Yeah, maybe not. Alright. So, What is this called? What does a funnel do? It doesn't filter it. We just use it to pour things inside. It's very simple. Okay. Now, look here. Can someone define for me? What is this? Don't name it. Define it. It's a strong acid. Why is it a strong acid?
Ionized is completely water concentration of hydronium ions. 1% at a time.
Talk to me. Is this a strong or weak base? No. This is it a strong or weak base?
Amen.
Strong base.
Show yourself.
Okay.
Know yourself.
Guys, let's be quiet. This one is it a strong or weak base?
Sodium carbonate. Weak
It's a weak base.
base.
Sodium carbonate. Guys, carbonate, it produces what? If I add the acid and a carbonate?
Salt water.
And carbon dioxide. Perfect. Oxalic acid, what's the formula of oxalic acid?
CO.
True, ne? Okay. So this is oxalic acid, and then what we're gonna do? We'll start. Okay, what is this?
Water.
Water. Ne? Now, it being water, is it acid or a base?
Oh, yes. Woo,
Alright. So what we're gonna do, ne? Vanessa, go fetch me a spoon there. If there is. And measure everything. So what you guys gonna do in groups, ne? First of all, you're gonna measure the mass. It's fine. Come with a thing that measures things. It's called a kitchen scale. Okay. So, is this solid, liquid, or gas? Solid. So now, I'm gonna edit this way. Guys, if you wanna talk, can you please go talk outside? Yeah. What I'm doing, man, this is what I call a solution. Ne? This is a solution. Why is it a solution? Because I'm mixing something in water. Now, water is the solvent. Ne? The small thing is called the solute. So in a solution, there's a solvent and a solute. Now, this is going to sound confusing, but it's just listen. The solution is a mixture of the solute inside the solvent.
Okay.
Ne? So if I put the solute inside the solvent, then it's called a solution. Alright. And then what we're going to do, we're just going to, guys, I'm just increasing the rate of reaction. Ne? What's the significance of me stirring? I'm increasing the what? Number of collisions per unit time, so that it has the correct orientation and it has effective collisions again. Which what I aim? Now here I'm just increasing the surface area. Ne? So here I'm not increasing the kinetic energy. Now you see it has dissolved, but not completely, so it's weak. Ne? Alright. What did I add there? Oxalic acid. So this is just oxalic acid. This is oxalic acid in an aqueous solution. Ne? It's still oxalic acid. I close it. I put it there. And then where's my sodium carbonate? No, I'm not looking for this one. Where's my, yeah. Guys, why can't I mix a weak base with a weak acid?
I keep it there. Yes.
It will take time for them to react, so I need something strong. So 1%, just remember this is the oxalic acid. And then you are also going to add these granules of sodium carbonate. What is this? Sodium hydroxide. Ne? And then I'm adding water. Ne? Okay. And then, guys, you don't mix with the pipette, ne? It's just that I don't have a spoon. Yeah. What if it breaks? Good question. Someone quickly resolve this. These two things.
Someone.
Guys, okay, time to do it. Assistant. Alright, continue. Any questions so far? That's why I said you guys are gonna use a scale. Okay, I'm just showing you how to do it. Alright. So now what you're gonna do? Guys, you struggle with the reading. What do I have here? Abel solution. I'm gonna edit. Okay, let me show you how this thing works. Yay! Relax, guys. Guys, this thing is too delicious. Use a Shina one.
You're making weight now. It's okay.
You know.
Alright, has it dissolved?
Not yet.
Okay, so, hold. Okay. So how do you work this thing? Inale mbobo ne. So mbobo I don't know mbobo kinga school. So yeah, it has a hole. It allows the thing to go through. Ne? Very smooth, guys. We need accurate results here. Okay, and then it's doing something. Ne? So now I'm gonna clean it. Now it doesn't matter the amount of water you add because water can act as an acid or base. Ne? So we are just gonna try to clean this thing. Ne?
Yes, dissolved.
It has dissolved. We thank the Lord. Ne? Now let me just close. Someone close. Please tell me what's the reading of water? 14,4. Now, guys, with is this a pipette or burette? With a burette, what you do, you measure it from the. Do you see the shape? The batch-like shape. So the bottom part. That bottom part, you measure from there. Okay, good question. What's the SI unit? Everyone must remember. This is measured in a cm3. What's cm3 called? Centimeters. Cubic centimeters. So you must convert it to decimeters. So it's measured in milliliters actually. So let me. So this thing is measured in milliliters, and milliliters is the same as centimeters cubed. So you divide by 1,000 to get the decimeters. Can you see here? Those who can see, it's actually written centimeters cubed. 25. Okay. So now let me continue filling it. Okay. See. So has anybody dissolved? That's fine. Okay. So which indicator am I gonna use in this experiment? Yes?
What are we trying to indicate?
Oxalic acid.
Are we using that orange?
Orange.
Perfect. So when you use a weak acid and a strong base, you use what?
Phenolphthalein.
So with a phenolphthalein, gonna need a dropper. Okay. Go get me a dropper. Something that drops.
Next level.
Alright, and then what you do then, you're gonna use stoichiometry to measure the concentration here. So how can you get the concentration here?
Equals to N over V.
C is equals to N over V. How do you get N? M over M. So you measure the mass and then get the volume is given.
Okay.
So you just check what's the volume. Yeah. You measure it. Me, I'm not doing the action. I'm showing you how to do it. Guys, you must remember we are live. So let's talk properly. Alright. So what am I doing? I'm adding this. I didn't close. Can you just hold it? Okay. Guys, please be careful. This is oxalic acid. Be careful when you're adding the oxalic acid because it's like a speed. It must get. Guys, don't worry, oxalic acid is a weak acid, so it's not so dangerous.
Not so, but it's still dangerous.
Guys, there's no English word for salad.
There is, regardless.
You put the player aside.
Alright. What did I do? What you guys in your group, you're gonna measure here at 0 again. After measuring at 0, you're gonna open. And then this is oxalic acid. Guys, this one pours water through. It come out. Okay, while it out, so that we get accurate results. And another thing, we wanna put it drop by drop. We're not gonna pour everything same time. Drop by drop. I hope you guys are taking notes. Okay, tell me when it gets to 0. Is it 50? Oh, to 50, is it getting there?
It's 25.
Oh, to 25, is it almost there? Is it 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 there?
No,
It's there.
it's there.
No, we're not doing I'm not going to measure the thing.
So, now what you're gonna do, you watch what this is, you know what this is. So here is what oxalic acid again.
Yes.
Now, where's my second? Let me use this one. Guys, is this spirit working? Can you hold this? Guys, you don't use the pipette. Guys, don't just keep quiet.
What's the function?
Okay. So, Mona Kinaling. Is it this one?
Yeah.
Guys, where did I put the sodium?
The one I was telling you.
Yes.
Is that one you took it here?
Is it this one? Okay. Alright, it's fine. Alright. Here is sodium. Okay.
You need to find it.
No.
No, where's the other funnel? We don't want to mix them.
Here.
Machine trainer.
What's it? Is it at 0 yet? Now, with this experiment here, anarchy sodium hydroxide. So with this one, we don't know what volume. We want to find out what's the concentration of this, so that it reaches equilibrium. So what I'm gonna do, give me, where's the oxalic acid? I put the oxalic acid. Where is my dropper? So what you're gonna do, take this dropper, take it out.
What is that?
Now, good question. What is that? Actually, and then put in 5 drops. Count with me. 1, 2, 3, 4, 5. Okay. Then I put the rest back. Okay. So what you're gonna do? You then get a white. You're supposed to get a white. What's this thing? Something white. Is there anything else?
The pipette.
Yes. reach here, and then
Is it straight?
is it straight? It is not, guys. Even sometimes when people use the pipette, they miss.
This is not
Serious, guys, people do miss.
They miss what?
What do they miss?
The white throne.
The whispering eye.
Alright, guys. Look. Look, guys. Look. Now, come closer. What color is it? Colorless, ne?
Colorless.
What's the function of the whatever? What's this thing? Indicate. To change color when it has reached an end point. What is end point?
The point at which the indicator changes
the
color.
The point in titration where the indicator changes color.
Perfect.
Yeah.
Alright, just say. Okay, now look here.
Is that pink?
What color?
Says one again. Whoa,
And then now, what you guys gonna do? Look. Don't get too excited when it's pink now, ne? Because look, you have to shake it. Shake.
Yes.
lights.
It has not yet reached the end point. Did you see I shake the first time? Now must be careful how many drops I add. Shake. Nice. Now, it's only gonna reach end point if I shake and it doesn't change back. Ne? It's like, you know, some witches, ne? Some of you don't know this. At night they are like dogs and cats, and then they change back to people. And then there are times where people pray, and then they cannot change back to, and then you find them naked. Yeah, you find them in the morning. Guys, these people they know. Alright, wait, guys. Look. Has it reached end point? Let's check.
Yes. No.
Yes. Do you see now?
Equilibrium.
It did not change. It didn't change color back. So now it has reached what?
Equilibrium.
End point. Ne? And then we are done with the experiment. Now wait. What is the volume that we used?
From 50 to
From 0 to
from 0 to
Is it exactly what?
12.7.
No, guys, I said to look at the what?
The bomb.
The bomb.
12.7.
No. 12
13.9.
comma? 13.9. We read from here. 12 comma? 12 comma? 12.1. Bring it closer.
Yeah, it's 12.1.
Let's see for evidence. Yes, 12.1. It's fine. You can go back. So now it has reached equilibrium. You can now use calculations. Now what you need to do, I'm just doing this for you so that when you guys do it, you don't get confused. You do an equation. Do you know the equation for what we just did?
Not read.
Do you know the formula of oxalic acid? Yes. Do you know the formula of sodium hydroxide? Yes. What is the acid and a base gonna produce? Salt and water. Ne? So that's gonna be your equation. Ne? And then I'm sure it's also in your books. So now it has reached equilibrium, and then you might do it today, you might not do it today. But as long as you know how it's done. Guys, what do I have here? It's just what? Okay, let's check what is in here. Nice. Guys, is it water if it changes color? No. Water doesn't change anything because it's an ampholyte. Ne? So if it's not water, what is it? What's here? The opposite of whatever is in here. What was in here? Sodium hydroxide. That means the here is sodium hydroxide. Oxalic acid. Alright. And then you check again when will it reach end point. Mix. If you mix and it doesn't change color, it has reached the end point. Are we clear with that? Okay, beautiful. Alright, what's the time?
14 past.
14 past 2. Okay, wonderful. So, put that thing on. Guys, have faith. So, everyone, let me just give you some notes. Everyone sit.